Dan Moore is the head of developer relations at FusionAuth, and he's been intrigued by Go for years, and he used to support an ETL tool written in Go. As a former CTO engineering manager and a developer, he has been writing software for checking watch, doing the sound effects, for over 20 years. And this talk is about JWT, and well, why should you care about this?
Thank you all for having me. I'm coming to you from snowy Boulder, Colorado, USA. So I hope you're enjoying snowy Berlin. And I would just also put a plug in to do a talk because I organize another meetup here in Boulder, and it's just a fantastic way to learn about something or dive deeper into something. And the meetups that I've been to have all been really, really friendly audiences. So just a pitch for that. I'm going to talk today about what Go developers need to know about JWTs or JWTs. Real quick about my employer. We are a drop-in user data store. Something like Okta or Auth0 are our competitors. We have multiple different editions, including one that is 100% free. It's our community edition. The other editions have support and some premium features, but the community edition supports multiple different OAuth grants, SAML, passwordless. It has a consent model. You can model families in there, and a whole lot more. So if you're looking for an identity store or identity provider, I would suggest you check out FusionAuth. And how it's relevant to this talk is that we produce a whole lot of JSON Web Tokens. That's the last you're going to hear about FusionAuth. I just want to get that out of the way. Let's talk a little bit about me and my background. Actually, who cares? You all didn't come here to learn about Dan Moore. You came to learn about JSON Web Tokens. Questions. This is my usual question slide. I didn't get a chance to edit it correctly. As Natalie said, we're gonna have a panel afterwards with somebody else who is also done talk about JSON Web Tokens, so save them. Although if I do lag or otherwise freeze up, please do tell me that. I have the chat open. All right, so let's get to the meat of the conversation. So JSON Web Tokens, they're pronounced JWT, which was news to me when I got into this position where I started doing more auth stuff, but they are an IETF standard, 7519. And what they really are stateless portable tokens of identity. And so that means that you can have an identity provider like FusionAuth or Auth0 go ahead and authenticate a user, hand you back a token, and then that token, you as a consumer of that token or a client holding that token can present that around and be sure that it came from where you think it comes from, and you don't actually have to have the token get validated by the user management system. So it's really great for APIs or single page applications. As it says here, they're produced by a lot of different identity provider servers. They are also used as bearer tokens, and that'll have some security implications we'll talk about in a little bit. So I'm going to kind of walk you through a couple of scenarios with a service-oriented architecture and illustrate why JSON Web Tokens might be a good fit. As mentioned in the introduction, I'm an engineer, and not, one of the fundamental tenets of engineering is that not everything is good for every solution. So I'll walk you through a couple of scenarios, and then we'll see kind of where JSON Web Tokens make a lot of sense and where they might not. So we have a typical, in this particular case, it's a little bit over-engineered, right? You probably don't need two different services for a to-do application, but we're using this for purposes of illustration. And you have clients over there on the left. You have two different APIs and the data stores that back them. So the user API is going to store user information, and the to-do API is going to store to-dos. Pretty typical user API. We have users, they map to roles. And to-dos just contain to-dos. So if this was a monolithic application, then this user ID here might be a foreign key. So this is the to-dos. This is how the to-dos table looks in the to-dos data store. And user ID might be a foreign key into the users table, but that's not really possible with a distributed application. But otherwise, and other than that, it's a pretty typical, to-dos data store option. I might augment it and add like a done check, Boolean, or the data was created. But again, this is an example application. So how the user proceeds through this is, first we have to know who the user is before we can display their to-dos. So the client's going to post credentials to the user API, which is going to validate them, make sure that the password is correct. Typically it's a username and password. It could be something else, but validate that the credentials are correct, and then look up the user information and pass that data back to the client. Now, this is what the data might look like. Obviously there'd be bits that would be changed, but it's going to have information about my ID, my name, other information that's going to be useful to the client to display the to-do application and also to find the to-dos. So in this naive implementation, the client extracts the user ID from the JSON that was passed back and then creates basically an API call that goes up to the to-do API and says, hey, I am trying to display the to-dos for user ID 42. Please hand me all those to-dos. Now, some of you that are maybe thinking like, whoa, that seems like a really bad idea. And I agree, it's a dangerous implementation because a malicious client could do some things like, examine the payload it's got, understand that user ID 42 probably means that there's 40 or more other users in the database, and try to find somebody else's to-dos, right? And something like, I need to go get milk after work today should really be kept private. I'd like that. But more seriously, it's obviously a huge gaping security hole, so don't implement things that way. Let's do things a little bit better. So what we can have here is the user API, instead of handing back a user ID that is going to be passed from the client to the to-do API, the user API is going to create an opaque token. And this could be just a random string of digits. It could be a random string of alphanumeric characters. It doesn't really matter what it is. What matters is the client can't introspect it and learn things about the system or iterate on it. So that token will get generated, passed to the client. The client passes that to the to-do API. Now this to-do API, this opaque token shouldn't be a link into the to-dos, because otherwise you run that same problem where you might have somebody kind of iterating things. You don't want to do that. So what you have to do is have the to-do API actually go to the user API and say, hey, here's a token. Is this valid? What's the user information about that? Then the user API looks at that token, says, yeah, that's Dan Moore, that's user ID 42, passes back the information, and then the to-do API looks up the information from the to-dos database. So this is a good solution. We've solved one of the gaping security holes, which is always a good idea. It does have some downsides. You have to maintain this user token mapping. So you have to find some place to put it. It can be very chatty, because anytime any API gets that opaque token, it needs to talk to the user API. And that's one of the biggest issues, is it couples the user API to pretty much everything. Any API that wants to deal with any kind of user data has to talk to the user API, which means you have to scale the user API. If the user API is unavailable, that's problematic, because the whole app basically falls down. So here come JWTs, or JWTs, riding to the rescue. So in this particular case, the JSON Web Token is generated, and this is crucial, signed by the user API. And a quick aside here, there's two kinds of JSON Web Tokens. There are signed JSON Web Tokens and encrypted JSON Web Tokens. I'm going to spend most of my time talking about signed JSON Web Tokens because they're more common in my experience, and that's just what I want to focus on. So that will have some ramifications in terms of security things that I'm going to say a little bit later. But anyway, the user API signs the JSON Web Token and then passes it down, and then that is presented to the to-do API, which has access to verify the signature. So the to-do API now can look at the JSON Web Token, which is basically structured JSON data, the same as that user data that we saw a few slides ago, or something similar, I should say, not exactly the same. And it can know, because it's validated the signature, that that has not been changed over the wire. That means the To-Do API can go to the To-Do's data store, resting assured that that user ID is something that that client was able to get. And so it hasn't been tampered with. And therefore, there's no connectivity needed between the To-Do API and the user API. You can sign JSON Web Tokens in a couple of different ways, and we're going to talk a little bit about that later. And the other thing that's worth noting here is that they can contain roles, other metadata, pretty much anything you can put into a JSON object, you can put into a JWT. So this is the a JWT. So if you Google JWT debugger, you will find numerous ones out there. You could cut and paste this and put it in. It's a real live JWT. There's 3 parts to every JSON Web Token. You have the header, which is the green. You have the payload, which is the blue. And then you have the signature, which is the tan. So they're separated by periods. And each of these is URL decoded, or sorry, URL encoded. So this is the header. And the reason they're URL encoded is because they are put into HTTP headers or other places that don't really deal well with curly braces. So this is just a way to make it very easy to transport them around. The header contains information like what key was used to sign this, what algorithm is this JSON Web Token signed by, other metadata type of things. The body is where things get interesting. This is where you can put your interesting business level data. And there's the keys of this JSON object are called claims. And there are standard claims, and then there are non-standard claims. So the standard claims are defined by the RFC and have certain meanings. Except for in rare cases, the format of the standardized claims are not specified. So the first 4 here, ISS, EXP, AUD, and SUB, are all standard claims. And I'm going to kind of walk through them. So ISS is the issuer. So that is the entity that created this JWT. So in this particular case, it's identified by a domain name, but it could be identified by an ID or a UUID or a random string. You don't really care. But what's important is that both the producer and the consumer of this JSON Web Token agree on what valid values are. EXP is the expiration date of the JSON Web Token, basically seconds since the epoch, the Unix epoch. And obviously that's a pretty important thing to put in. Otherwise, JSON Web Tokens can be good for a long time. Basically, you always want to put an expiration claim in. Odd is either a string or an array, and that is who should be consuming this token. Who is this token for? So in the example I gave earlier, the ISS, or the issuer, was the user API, and the odd, or the audience, was the to-do API. The sub is the subject, and so that is who is this JWT about. In that case, case that I illustrated earlier, that was Dan Moore. And then name and roles are just some extra claims that you can add on your own. And so you can put in more if you want. And that the point there is really less to show that they're there and more to show that you can basically put in arbitrary JSON data structures. It doesn't have to be just strings or numbers. The signature is, I'm not going to show you what that decoder looks like, but you can sign with a variety of different formats, different algorithms. And the main differences there are, is it public, private key pairs or symmetric, which is what HMAC is. And then the other question is kind of what are the speeds you need? That's the main difference between the different public-private key pairs, RSA or elliptical. So finally, at the end of the day, we have this statement where the to API has extracted the JSON Web Token. It has looked at those claims and validated that this is a JSON Web Token that was for it, that it should consume, and then it extracts the subject claim, and then it can go ahead and go into the to-dos data store. Going to skip questions because we're saving them all for the panel. So whenever I post JSON Web Tokens to any kind of technical community, Hacker News or whatever, people come out of the woodwork and say, oh gosh, JSON Web Tokens, JWTs are horrible. No one should ever use them. Everyone laughs at them. And my response is always, yes, they can be used poorly, but they're very powerful. They're supported by very many languages. They're relatively easy to understand. And so, yes, you can misuse them, but you can misuse anything. So to use them correctly, I'm going to kind of walk through 3 different ways that you could misuse them that you should avoid. So the first is you want to make sure that you understand the configuration options. And one of the easy ways to do that, to leverage the wisdom of the crowds, is to use a library. There's a Golang library out there. I have not encountered any major language that didn't have a JWT library, so use one. Then you also want to make sure you verify your claims. And so I talked about the issuer, I talked about the audience. As a consumer of a JSON Web Token, which is my primary kind of focus here, although I can talk a little bit about being a producer as well, as a consumer, you want to make sure that you're verifying that this JSON Web Token was created by somebody that you know, right, that you expect, and that it was created for you. And otherwise, you should throw up your hands and just not treat this as a valid request. JWTs that are signed can contain arbitrary JSON data, but because they're just signed, they're not encrypted, that means that they aren't secret. That means that anybody who gets a hold of them who can Google JWT debugger is going to be able to read the contents of them. So you might have noticed that the subject and the audience for the previous JWT example were actually GWTs. They were not integers. And that's intentional on our part. That was a sample one from FusionAuth. That's intentional because you don't want to leak information about how many users you have, for example, right? If it was an integer and it said, 100,000 or 10, that might be leaking data to anybody who was able to find your JWT. And we just want to avoid that. So don't put any secrets in there. And then the last thing around this particular set of footguns is that if you're using a symmetric key, you want to make sure that the key is nice and long and random. There's actually open source software out there that you can find that will take just a signed JWT and it will try to brute force the key. And, I did it with a key that had 4 characters in it, and it solved it in about 30 seconds. So make sure your HMAC key length is nice and long. Another footgun that we see is, when you're using JSON Web Tokens as an access token, so you're presenting them to APIs, and those APIs are taking that as authorization information. You want to make sure that you store them carefully. You want to take care with these because they are bearer tokens, and so a bearer token is very similar to a car key. A car key doesn't care about who is holding it. It's going to just open for the person that is holding the key. So if you leave your car key lying around and they can identify, and someone picks it up and they can identify which car it goes to, they're going to be able to open the car up as well. I want to say there are ways to constrain JWTs to a given client. If you're interested in learning more about those, you can Google for Depop and MTLS. They are not super widely deployed, so I'm not going to spend a ton of time talking about them. So here's the example of a bad person, a bad client who has found a JWT and is now presenting it to the to API, and the to API looks like a valid JWT. It's checked the issuer, it's checked the claims, it's checked the signature. So it's going to go ahead and give those to-dos to the bad actor. which obviously is not really what we want to do. So we're trying to prevent the jot from being picked up. So as far as storing these tokens, our recommendation is generally to store them server side if at all possible, because that just gives you a much more controlled environment. If you can't do that, which with some single page applications you can't, or if you're really concerned about scalability, you may want to push those down to the browser if that's your main client. And in that case, you want to make sure you set those cookies to be secure and HTTP only, so that you can avoid cross-site skipping attacks. If you're pushing them down to a mobile device, then you want to store them, again, is either a secure cookie or using the keychain or the secure storage on Android, whatever the secure storage area is. But don't leave them lying around, I guess is the point I'm trying to make. The last foot gun I'm going to talk about is the none signing algorithm. And so the JWT specification actually allows you to say, hey, I know what I'm doing. I'm not gonna, I want to create or accept JOTs that don't have a signature. So that turns a JOT from something like this to something like this. So again, there's still 3 clauses. There's the header, the payload, and the signature, but signature is empty. And, this is what the header changes from, the algorithm of HS256 to none. And the fundamental reason that this is a bad idea is because if you don't have a signature, you don't have any guarantees of the integrity of the data inside the JSON Web Token. So, anybody could go ahead and create a JOT like this, and they could change the payload to be whatever they wanted to do, right? To give themselves admin privileges, to, poke at your system and see whether different people have accounts. Just, it really broadens your attack surface. The specification allows this, and the simplest fix is just don't allow none ever, right? No, don't ever create JSON Web Tokens with the algorithm of none. And if you ever see one, and you're an API consuming a JOT, just don't throw up your hands and immediately, return 403 or 404, whatever your standard HTTP status code is for things that you don't want to process, 400 maybe. But I used to be a consultant, and there's always it depends, right? There's always different situations. And this is part of the reason that the JWT spec is kind of longer and complicated, is that, and the reason why the algorithm none is even available is that you could conceivably have some other way to make sure the JOT is unchanged. And that could be, some other layer of client certificates. It could be that you are using JOTs on a private network, right, of private virtual VPC in AWS or something like that, where you're just absolutely positive there can be no nefarious clients on this network. And in that case, if you have client knowledge, right, some other way of verifying that the integrity of these JOTs is solid, and you have benchmarked to ensure that the signing, the CPU usage or the cost of signing JOTs is so high that you really need to be able to not sign them for performance reasons, then I would say it makes sense for you to use the none algorithm. That said, I have my doubts that anybody who is in this boat is going to be coming to an intro to JWT talk, but it's very possible. So let's talk about public-private key pairs. So the nice thing about signing with these is that the issue with signing with a symmetric key pair is that you have to distribute the secret. So again, back to my user and to-do APIs. The user API uses some great secret to sign the JSON Web Token. The to-do API, in order to validate that token was signed by the user API, needs to have access to that same secret. That works fine if you have a small application, or everything's being done by one team. Then you can roll the deploys, and you can just kind of stick that secret in the environment variables or whatever secrets manager you have. Works great. but doesn't scale well organizationally. If you have a user API that you are making available to people across your organization outside your department, you may not want to share that secret with them. Even more so if they are outside your company and you're just, having people that are consuming the JWTs that you are producing outside your organization, you're definitely not going to want to share a secret with them. And public-private key pairs let you sign a JSON Web Token with a private key and have someone validate it with a public key. The other reason why you might be interested in public-private key pairs is security. So that to-do API that has access to your shared secret, if it's compromised or there's bad code written, or even if it's just nefarious, then it can sign JSON Web Tokens in a way that is indistinguishable from those that are signed and created by the user API, because it's the same secret. And so if that gives you shivers, then you probably want to look at using public-private keys instead of HMAC. Key rotation is also easier. Now there's no such thing as a free lunch. Public-private signing of JSON Web Tokens is a little more complicated, and it's definitely slower. And I've done benchmarks, not in Go, but I did them in Ruby, and I found, again, I think it was about 5 times slower to use public-private key pairs. It depends on the algorithm that you choose and whatnot, but it's definitely going to be slower. So how does a public-private key pair kind of flow work? That's different than in a way that's different than the previous one that I illustrated. Well, so again, the user API is going to sign the JWT. They're going to sign it with a private key. It's going to get passed down to the client. The client's going to pass it up to the to-do API. Now the to-do API needs the public key to validate it. So could happen a couple of ways. It could have them pushed to the to the local environment, or even better, it can actually go out and ask the user API, hey, I need your public keys. And the user API can publish them. This particular URL is a FusionAuth specific one, but there is a standard out there called JWTs, and there's a well-known place for you to publish the public keys. And that way the to-do API can go ahead and reach out and grab those public keys and do the validation with, and be confident that the user API was the thing that signed the JWT. So this is what that endpoint might look like for an RSA key pair. If you have multiple keys, you can actually, in the metadata, you can put the key ID. And again, 42 is probably a bad idea because that lets an attacker know that very likely there are 40 other keys out there. But you could make this an arbitrary string. It doesn't need to matter. It doesn't need to be a numeric number. I'm not sure what other kind of numbers there are. But anyway, so you put this in the header, and then the consumer, right, the to-do API, can go ahead and reach out to the user API and say, okay, I need to find public key 42 to do that validation. So talking about refresh tokens, they're kind of a key part of the JSON Web Token ecosystem. They are, JWTs are meant to be short-lived. And the reason for that, again, is because they are stateless and portable, and they're very much like my car key, right? Anyone who finds my car key can get into my car. Therefore, it's kind of like, well, there's no real analogy in the real world, but imagine if you could hand out keys to your car that were time-bound. So you give a key to someone to park it at a hotel, and that key is only good for 5 minutes. Well, that's great. You wouldn't want to make that key available for 5 hours or 20 hours because they could go make a copy of it or otherwise do bad things with it. Refresh tokens, on the other hand, are supposed to be long-lived. And the main purpose of a refresh token is you can present a refresh token to a identity provider, to the user API in my example, and get a new JWT. So there's this compromise between, if you were building a system with JWTs and you didn't have refresh tokens, you could either make the lifespan of the JWT very short and then force the user to log in and get a new JWT regularly, right, every 5 minutes or something like that, which obviously is not a great user experience. Or you can make the JWTs very long-lived and then have to worry about them getting stolen and used by bad actors. Because basically you can't revoke JWTs. And I have a whole set of slides in a little bit about, ways you can work around that limitation. But in general, the best way to revoke a JWT or to have a JWT be not useful anymore is to have it expire. That's the surest, simplest way. So how does this refresh token pattern work? Well, what happens is the user API generates not just a JWT, but a refresh token. And that refresh token could be in JSON Web Token format. It could be just an opaque token. We don't really care what it is. In FusionAuth, it's implemented as just a random string. Those get passed down to JWTs and to the client, excuse me. The client presents the JWT to the to-do API repeatedly. And so the user is adding to-dos, maybe they're deleting to-dos, checking them off their list. And as long as that JWT is still valid, the to-do API can say, yep, you still have access. Now, let's say the to-do is only good for 5 minutes, or sorry, the JWTs are only good for 5 minutes. In 5 minutes and 1 second, the client will present this JWT to the to-do API, and the to-do API will go through all its validation and say, whoa, hey, this is not a valid JWT. Sorry, I can't give you access to the to-dos anymore. The client can catch that exception and say, this JWT was unauthorized. I'm not sure what's going on. And it could look at the JWT, or it could just say, I'm going to try to get a new JWT. And so if it wants to get a new JWT, it's going to pass that refresh token back to the user API. The user API will look at that refresh token in its database and say, oh yeah, this user is still logged in. They haven't logged out. They have paid for their to-do app access. Nobody's locked their account. And so I'm going to create a new JWT, pass that back to the client, and the client then presents that new JWT to the to-do API, and basically can do that repeatedly. So this is where there's additional layers of complication to kind of extend the authenticated state of the session, I would say. So the JWTs get turned over so that you aren't, you don't have the security risk of them lying around, but they aren't, but you don't force user log in repeatedly. So now I'm going to talk about things that are not directly related to JWTs, but are kind of something you want to think about if you're building a system that's going to use JWTs. So the first thing you want to think about is deleting users. And if you were in a monolithic application, you might use onDelete cascade, which would basically delete all the rows of the any tables that have foreign keys into users. And this is important because of things like the GDPR. You want to be able to say, okay, we've authoritatively deleted all of your user data because you asked us to. But in a distributed system, you don't have onDelete cascade. And so you need to find out some way to replicate the delete requests from, from your client all the way across your application. There are two main ways to do this. You can push the complexity to your client and force them to make deletes across all the different APIs. This has some problems because what if a network request fails? What if there's a new API that's introduced, but you have an old client that doesn't know to call out to that API and say, hey, delete this user data? So a better solution is to push the complexity to the server. And in this case, you have one delete request that happens to the user API, and then that user API is responsible for firing off a bunch of webhooks. And any interested API that is in your system can register for those webhooks. This is not part of any standard. This is just a pattern that we've seen, that we've implemented, that you might find useful if you're building your own system. So then the to-do API can take care of cleaning up its data. As far as logout, you are in a JWT-based system, you're pretty much limited to revoking the refresh token. This is the flip side of the fact that JWTs are stateless. And how that works is that you have the client issues a logout request. It's going to take care of the JWT on its system and the refresh token and making sure they're deleted. And then because of the logout request, the user API can delete the refresh token. And that means that the refresh token can no longer be used to mint new JWTs. If you have more than one system or multiple different refresh tokens, make sure you revoke all of them. So you'll notice that I quickly sped by the fact that there might be a JWT hanging out there that could still be presented to the to-do API. And this gets back to what I said earlier about revoking JWTs. And the answer to this question, which is one of the ones that we get asked quite often, is sort of. So there are a couple of different options. You can, there is a RFC out there, 7009, that is something that an identity provider can choose to implement that does give you the ability to revoke JWTs. The problem with that is that then you're back in that world where the to-do API has to check with the central server to know. It's really hard to distribute that information. There are other options. If you have a user account that's been breached at a certain time, you could rotate the keys. And that is definitely a bit of a kind of a light the world on fire option, depending on how many JWTs have been signed with that same key. Because basically any key that JWT has been signed with, any key that has signed a JWT, excuse me, any JWT that has been signed with a key is now going to be invalid if you rotate out that key. So if it's an admin account, it may make sense to do something that's that drastic, but logging all your users out is a pretty unpleasant user experience and should only be used in emergencies. Another option is what I call a time window solution. It's also basically you're building up an allow list or a deny list, and we're going to kind of walk through that. So in this case, you, in addition to having webhooks fired when a user wants to be deleted, you can also have webhooks that fire on other interesting events, and logout might be one of those. And in this particular case, we call it the refresh token revoke event, but you can call it the logout event, whatever. And that tells the to-do API that this user has chosen to log out. Therefore, the to-do API now, in addition to checking the signature of any JWT that comes in, the audience, the issuer, all those things that it should check, also should check, hey, is this JWT about a subject that has logged out? So that is on the deny list. So you could imagine, Dan Moore, user ID 42 logs out, 42 gets stored here. It could be in memory, it could be in Redis. And the to-do API, when presented with a JWT that somebody else has grabbed, and it has Dan Moore, user ID 42, will check that data store and say, oh, yep, this person has logged out. Now, there are a couple things here. The first is that you're basically solving the stateless nature of JWTs, or you're working around the stateless nature of JWTs by pushing state out to all the APIs. And so, again, you can have additional complexity inside all your consumers of JWTs because you want to be able to immediately revoke access. Another path forward is to have much smaller, shorter timelines, and then just accept that a JWT might be good for a minute after a user is logged out. And if somebody bad gets a hold of it, they have access for a minute. I'm not going to kind of try to dictate your security posture. These are choices you have to kind of make. The other thing that you want to think about in this scenario is a very real possibility is it's 1 o'clock, Dan signs in. 105, Dan gets another jot. 107, Dan logs out, but the jot's good for another 10 minutes. And then 110, Dan logs in again. And so there's that 3-minute period of time where you want to make sure that no jots that are assigned to Dan are actually valid for the to API. But at 110, that new jot, you want to actually make sure that you you allow access, right? Because it's a new authentication regime and it's a totally new situation. And so you shouldn't, just because you've revoked my jots in the past doesn't mean you should revoke my access entirely. So the way to deal with that is to think about how long jots last for and then do some simple time math. So let's assume that I log out at 1:12:47 and my jots are good for 30 minutes in my system. So that means that a jot created right at the time of logout would expire at 1:42:47 in the afternoon. That means that a jot created 1 second ago will expire at 1:42:46. So a jot created just before I log out would expire at 1:42:46. That means that because I've logged out, any jot that expires before 1:42:46 is invalid. So that's what I want to store in that deny list. It's not just the subject of the jot, but also when the expiration time before which jot should be invalid. So, and again, we're just taking care of this red zone, right? This is the time when I log out and it's good for 30 minutes. Now I can, again, as I mentioned earlier, I can deal with this by shortening this red zone or by rotating keys. So I'm going to do a quick demo of code. And as I mentioned in my intro, or as was mentioned in the intro, I've tinkered with Go. I've gone to a GopherCon. I am by no means a professional Go programmer, so I cobbled together a couple of examples. I'm going to just go over 2 of them right now. And this is Apache license code. There's a link in the presentation, so you can go ahead and kind of download this and play around with this if you want. HMAC, verify claim. So, and this is all in one file. You're going to probably break this up. Basically, this is pretending to be the user API from line 13 through basically 33. And then below that, we're pretending to be the consumer of the jot. So this is a producer, and obviously not a very dynamic producer because everything's hard coded, but this is how you would sign a jot in Golang with the HMAC algorithm. We're putting various claims on here. Again, it doesn't need to be just strings. You can see on lines 23 through 25, I'm creating a data structure. I'm putting that into the jot. And this is going to be good for 5 minutes. And then this to-do API, this is where I'm actually doing some validation and printing out the claims, which are really what I'm interested in, right? I don't really care about the header, and I care about the signature insofar as it just guarantees the integrity of the data. So if I were to go you can see that this is the jot that I could put into my authorization header. I could use this bearer token, and then this is the output of the claims map. And then there's one other bit of code I want to show you that you may have noticed didn't do a whole lot of checking of claims. Here, the generation is exactly the same. So the user API side is exactly the same, but the to-do API is a little bit longer here. We're checking the audience and the issuer. And I'm pretty sure that this library, which is just the JWT Go library, does check expiration. If not, I should definitely update these examples to check the expiration time. In fact, let's see if it does check the expiration time right now. We'll do this, actually, go run. So that works perfectly fine. And if I change the expiration to be times -5, it should blow up. It does not blow up. That's not good. Okay, so I'm gonna need to change that. I just got these examples done this morning, but I need to change that because you should absolutely check that the expiration time is not in the past. So those are the 2 bits of code I wanted to show. And again, there's a link in a slide or 2. So as far as thinking about JWTs and Golang, what are you trying to accomplish? If you're just trying to parse a JWT, then I would use a library. JWT Go is great. Again, make sure you check your claims and make sure you check the expiration claim especially. And then as far as authorization, you can put it in a filter. It depends on where you're consuming this, but you can put it in a filter if you're using a web framework. I've also seen it done in an API gateway where kind of all of the requests are routed into one central location that does the JWT validation, and then it kind of forwards the requests on. Quick tools, and I'm almost done. This is the second to last slide. Here's one of the debuggers out there. Again, there's a number of them. Here's the example code that I just went through, and then I wrote about 3,000 words on how to build a secure JWT from a bunch of different perspectives. And if you're interested in learning more, I'd suggest reading that. And that's it. So thank you for your time. I really appreciate it, and I'm looking forward to the panel discussion.
Thank you very much, Dan.